Hello, in this video I'm going to recap with you arithmetic or linear sequences, and we're going to talk through how to get a formula for the nth term and look at some GCSE style questions as well at the end. Before we get started, make sure you've got pen and paper to hand, and you can also use a calculator, but you probably won't need it for most of these questions. Okay, so first of all, arithmetic or linear sequences, as they're sometimes called, are sequences where you always add or subtract by the same value to go from one term to the next. This is the simplest kind of sequence that you're going to deal with at GCSE, and it's probably the sequence that you've seen most before, okay, because you will have seen it a little bit in year 7 and 8 and also year 9. So this sequence here is an arithmetic sequence, and I know that it's an arithmetic sequence because if I look at the gaps between the terms, every single time we are always adding 6. Okay, so that is what makes it an arithmetic or a linear sequence. This number that we're adding or subtracting every time is known as the common difference. So for this sequence here, the common difference is positive 6. Whenever you have an arithmetic or a linear sequence, the formula is always going to be in the form some number times n plus or minus some number. Okay, so we're going to go through how to work out the formula for the nth term of a linear or an arithmetic sequence. Okay, so to help us think about the formulas, I'm going to encourage us to think about a linear sequence or an arithmetic sequence as a certain times table that's had a shift happen to it. So first of all, let's generate the sequence, which I'm going to describe as the 4 times table shifted up 3. So to help us start off, I have written the 4 times table out, the first 5 numbers in the 4 times table. What I'm now going to do is I'm going to shift each of these values up by 3. So I'm going to add 3 to each of those values. 4 plus 3 is 7, 8 plus 3 is 11, 12 plus 3 is 15, 16 plus 3 is 19, and 20 plus 3 is 23. So this sequence that I've written here is the 4 times table shifted up 3. You'll notice that as I go along, I'm adding 4 every time. Okay, so it's very similar to the 4 times table because we're still going up 4 every time, but the numbers we've got here are just 3 higher than the 4 times table. The nth term for this sequence is 4n plus 3. Okay, now let's go the other way. Let's have a sequence and work out the formula. Okay, so here is our linear or arithmetic sequence. The first thing I'm going to do is I'm going to work out the common difference. So from 5 to 12, we need to add 7. We add 7 again here, and again, and again. So this sequence is going up in 7s. The times table that goes up in 7s is the 7 times table. So I'm going to write the 7 times table above so we can work out what the shift is. So we know it's the 7 times table. Now, if you've chosen the correct times table, you should find that every single time the shift is the same. If it isn't, then the problem is either you've chosen the wrong times table or you're not dealing with a linear sequence, so you need to do something different. But looking at this, I can see every time we need to go down 2 from our times table to get to our sequence. So I can describe this sequence as the 7 times table that's been shifted down 2. So my formula for un, term number n, is going to be 7n minus 2. 7 times table shifted down 2. Okay, so following that same process, see if you can find the formula for the nth term of these arithmetic sequences. Okay, hopefully you've had a go at least one or two of those. So what I'm going to do is I'm going to talk you through the first one in full, and then I'm just going to give you the answers to the later ones if you manage to get onto them. So for the first one, we need to start by looking at the gaps in between each of the terms, and hopefully you'll notice that it's adding 3 each time. So because it's adding 3 every time, that means it's related to the 3 times table. We then need to work out the shift. So if we write the 3 times table above our sequence, we can then compare our blue times table with the original sequence to see what shift has happened. And every single time, to get from the 3 times table to the sequence, we have to add 6. That means that the green sequence that we had originally is the 3 times table shifted up 6. So the formula for term number n, un, is going to be 3n plus 6. The answers for the other ones are up there now for you to have a look at. Okay, now let's have a look at a slightly more difficult question on arithmetic sequences that uses the nth term. I'm going to work through the question. Does 67 appear in the sequence 4n plus 3? The first thing I'm going to do is I'm going to make my formula equal to the number that's supposed to appear in the sequence. So if this number does appear in the sequence, there should be some number n that I can use here to times by 4 and add 3 that gets me an answer of 67 out. So I'm going to solve this and see what n value I'd have to put in order to make that happen. Take 3 from both sides. Divide by 4. Right. What this is telling us is that if n was 16, or I was looking for the 16th number in the sequence, I would get 67. So the answer is yes. 67 is the 16th term of the sequence 4n plus 3. If you'd got a value out here like 10.5 or a decimal answer, then the answer is no, okay? Because for sequences, you can only have integer number terms. If you'd got out a decimal number, let's say 10.5, what that's telling you is that the value you've been given is in between the 10th and the 11th number in the sequence. Here are 2 similar questions. So what you'll need to do is set up an equation, solve it, and then make sure at the end of your working out, you write a statement relating your working out back to the sequence. Okay, so here is the working out that you need to show for full marks in an exam. First of all, we're going to make our formula equal to the number we're interested in. Then we're going to solve by subtracting 16 and then dividing by 4. Because n comes out as 10, that's telling us that 56 is the 10th term of the sequence that we were given. For the second question, again, we're going to make the formula equal to the number we're interested in. We're going to subtract 7, then we're going to divide by 3. We can write that as an improper fraction or as a mixed number. So because n is in between 22 and 23, that tells us that 75 is not in the sequence. It is in between the 22nd and the 23rd term. Okay, so here are two GCSE questions on arithmetic sequences. Have a little think about them and I'll go through the answers in a couple of minutes. Okay, so here are the answers explained. For the first one, even though it's a multiple choice, don't feel like you have to do it without any writing down of method. And one thing I would encourage you to do for multiple choice is try, if you can, to ignore the answers while you think about it, and then hopefully you'll reach the answer yourself so you can be really confident. If you can't do that, you can start eliminating answers you know aren't right, but AQA will try and slip in some incorrect but plausible answers. So by ignoring the answers while you think about it, that might be the best way of avoiding falling into traps. So looking at this sequence, it's going down by 2 every time, so it has a common difference of -2. That means we know that this sequence is related to the -2 times table. Okay, so the -2 times table goes -2, -4, -6, and so on. So we now need to look at comparing the -2 times table to our sequence to see what we have to shift every single time. We have to shift up 17. So this is the -2 times table shifted up 17. We could write that as -2n plus 17, or we could write it as 17 minus 2n. For the second question, we've got something a little bit more complicated here. We know that we've got 4 numbers, and we know that the difference between each number is 7. So we've got an arithmetic sequence of 4 numbers going up in 7s. We've also been told about what we get when we add the 4 numbers together. This is how I would approach this question. So first of all, I would call the first number in the sequence x. The second number in the sequence is going to be 7 higher, so x plus 7. The third one is going to be 7 higher than that, so x plus 14. and the fourth one is going to be x plus 21. Sum means all of them added together. So we've been told that when we add all of those together, we should get 6. That's looking quite complicated at the moment, so we need to simplify that equation. Then we're going to solve it. So first of all, we're going to subtract 42 from both sides. Then we're going to divide by 4. Now we've got now x is minus 9, but just remind ourselves that x was the first number in the sequence. So if x is the first number in the sequence and the difference between each number is 7, this is what our sequence is going to look like. So now we can just check that when we add those together we get 6, which we do.